Okay, so 2.4 is the final section in Chapter 2 that we cover. And this is really, it's called Surveys and Cardinal Numbers. And what it does is it really shows you how we use sets to organize data and to organize information so that we can pull just pieces of it out at a time. And so you're going to be doing a lot of Venn diagrams today, whether you decide to draw them yourself or you use the ones that are provided on Pearson. You will be examining them. I went through and did all of the homework this morning just to kind of see what kind of questions were asked and make sure that I have a good representation of all of them, and I feel like I do in these notes. Unlike a traditional math problem where 2 plus 2 is 4 and you can just solve it, these are a little bit more like a logic puzzle. When I was working through them, I was thinking it kind of feels almost like working a Sudoku puzzle. So if you've ever done those, there's some logic where you're looking at different rows or groupings to see where your numbers fall and thus logically deducing what number goes in which spots. That's kind of how these are going to play out. And that we're going to have a basic Venn diagram set up, and we have to figure out how to fill in the numbers based on these clues that they're going to give us about who fits where. So we're going to work through them. I will say, because it's more logic-based, it might take some more time. So don't get discouraged if you're sitting there and you're like, okay, this is a 2 or 3 minute problem. That's okay. Just know that practice will help you see the little patterns a little bit quicker and figure out how to fill these things in. So the first problem, because there's not really notes for today, there's like one tiny section of notes, and the rest of it is seeing how these problems are asked and how we're going to fill in Venn diagrams. So it says, suppose a human resource director for a marketing firm is evaluating a pool of job applicants with a general emphasis on digital and social networking skills, and specifically in copywriting, graphic design, and link building. The applicant's resumes show the following information. And this is like a real life scenario. If you have to do any type of hiring for a company, you're going to be separating people into different categories based on what it is you're looking for that job. So it says 17 of the applicants have copywriting skills, 18 have graphic design skills, 15 have link building skills, 9 are skilled in both the copywriting skills and the graphic design skills. 5 are skilled in copywriting and link building. 6 are skilled in link building and graphic design. 2 are skilled in all 3. And then 4 applicants have none of these skills at all. So what we're going to do, and the way your problems will be presented, is you'll have all of that information. And then on Pearson, since you have a copy of this, I'm scrolling up pretty quick because you have it in front of you. On Pearson, what you will be shown is you will have a Venn diagram already set up that looks a lot like this, where the big boxes are universe. That's our universal set, so there will be a little U in the corner. And then each of these will be labeled. We'll have our C, our G, and our L. C for copywriting skills, G for graphic designs, and L for our link building skills. And then in Pearson, they will list little letters in here like X, Y, Z, that in there, because then you're going to fill in the values down below in your answer boxes. But they give you this setup so that you can go ahead and start playing around and figuring out what goes where. And after you've filled in your diagram, sometimes that's it, and that'll be the end of the question. You just simply have to fill in the diagram, and then you get to move on. Other times, they will then ask you some questions based on your diagram, and you go back and reference it. So we're going to start by filling in the diagram, and then there are 3 questions that will go with this diagram. So they don't tell me. I do know based up here, my very first clue says that 17 have copywriting skills. Okay, that means in the C circle, there will be 17. But the problem is that doesn't mean that 17 only has C copywriting skills. Some of them have the graphic design skills. Some of them have all three. Some of them have link building skills. So I don't want to just automatically write 17 over here because there's 17 in this entire circle. So what I actually usually look for is, do they tell me how many have all three? Because then I can start at the middle and work out, and that's usually the easiest approach to filling in these Venn diagrams. So they do actually tell me how many have all three of the skills. 2 people have all 3 of the skills. So right here in the middle is where all 3 of my circles cross. That's where my C circle crosses, my G, and my L. So in here, I'm going to write the number 2. And then I have done that clue. And I kind of keep track of what I've done so I know where I've put my numbers. It also tells me on that last line, it says 4 applicants have none of these skills. So they can't do copywriting, graphic design, or the link building. So that means they live out here in the universe, but not inside any of our circles. They're part of the applicant pool, but they don't have any of these skills. So you know the odds of those 4 getting hired are probably not that great. But they are part of the application pool. Okay, so then I'm going to move up my list. It says 6 are skilled in the link building and in the graphic design. So if I'm looking at link building and graphic design, that's this space right over here. And it says there's 6 in here. But I already listed 2 here. So how many go here? 4, yeah. And then I've dealt with the L and G. I do a similar process for C and L. It says 5 are skilled in both the copywriting and the link building. So that would be this little subsection over here. But if 2 are competent in everything, that leaves how many for C and L? 3. You see how we're working this out? All right, the next one says 9 are skilled in both C and G. So what number goes up here? 7. Now we can start looking at those bigger numbers that are up top, where it tells us that 15 total applicants are skilled in link building. So 15 total people have to live in the L circle. Based on the information that we've already listed, what's going to go here? 6, yeah. Because if we have 3 and 2 here, that's 5. 4 makes 9. So 15 take away 9 will leave us with 6 who are only capable of doing link building. They can't do these other things. So then we're done with the link building. And we do the same thing for graphic design. Graphic design total has to have 18. 7 and 2 makes 9. 9 and 4 makes 13, leaving 5 left over. And then we're up to our very top, where we have 17 are competent in the copywriting. 7 and 3 makes 10. 10 and 2 makes 12. Again, leaving us with 5 that can do copywriting. And now we have this beautifully designed Venn diagram where it really shows how all the applicants are laid out. So if you are a hiring firm or you're part of the HR and you're looking for somebody who can knock out all 3 of these already without training, there's really only 2 people. If you're not really focused on these 3 categories and you really just want a people person, then you may actually look at the 4 people who applied that don't have these skills, because maybe these skills can be trained relatively quickly and these 4 people that can't do them are already above the game in terms of what they bring to the company in other ways. So now, what are the questions that could be asked? I meant to have these typed up on a page, but I do not. So question number 1 asks, how many are skilled in only copywriting? So how many are only skilled in copywriting, not skilled in anything else? 5. That's right. It's this number over here. We're not going to say 17 because all of these people are skilled in something else. So it's 5. How many have exactly 2 of the 3 skills? What do we think?
16.
Close. 14. Because it says exactly 2 skills. So when we're looking at where do only 2 of our circles overlap. Well, C and G overlap here, and G and L overlap here, and C and L overlap here. And we don't include this middle one because all 3 of the circles overlap here. And so we add up those values, and that gives us 14. All right, last one is number 3. How many total applicants were there or are there? Huh? Close. 36. Yeah. All we have to do is add up all the numbers we wrote down. So 5, 7, 5, 3, 2, 4, 6, and 4. If we add all those up, we have 10, 20, 36. So some of your problems, you only do the Venn diagram. Some of your problems, you will put together your Venn diagram, and then they will ask you a series of questions where you go back and reference that Venn diagram. Are there any questions on how we did that one? I think they're kind of fun. They're kind of like puzzles. Okay, let's flip over. Cardinality is the one bit of notes that you have for this one, because there's a little formula. Remember from previous sections that cardinality is the number of elements within a set. And so if I say the cardinality of the set is 5, that means there's 5 elements in that set. And so the nice thing about the cardinality formula is it allows us to come up with the union number or the intersect number or any of our individual numbers just based on this formula. Because they will give you 3 of the pieces and you will be able to figure out the 4th, to where it really becomes more of a plug and chug style problem. These are actually the very first style of problems that come up on your homework for 2.4. So the cardinality number formula states that for any 2 sets A and B, the following is true. The cardinality of A union B, so when you combine the 2 sets together, will always be the cardinality of A plus the cardinality of B minus the cardinality of A intersect B. So what it's stating is that if I want to find, which we could even draw a picture, the number of elements that are in A union B. Remember, A union B is where you take all the elements in A and all the elements in B, because you combine them together using union. Well, if I want to find the number of elements in here, what I do is I take all the elements of A and I add to that all the elements of B. But notice that when I do that process, if I take all the elements of A and then I take all the elements of B, I've added this middle section twice. Whatever they share in common, I have now added to the number twice, which is why we subtract one of those. That way we take out the duplicates. And that will tell us the actual number of elements that lives in the union without us double adding the middles. So this is a really nice little formula, probably something that I would write on my note card, or I would memorize it. So let's do one. It says find the cardinality of A. So we're going to use this formula, but we're going to be missing this part, the cardinality of A. So they're going to give us the other three parts. It says if the cardinality of the union is 22, the cardinality of the intersection is 8, and the cardinality of B is 12. So anytime I'm learning a new formula, I'm always going to write it out, because that will help me to memorize it. And if I write it out, then it really becomes plug and chug. Because I can say, okay, the cardinality of the union, well, they tell me that's 22. So I'm going to write 22 in place of that. The cardinality of A is what we are looking for. So I'm going to leave that. The cardinality of B is 12. And the cardinality of the intersection is 8. So now I'm just solving for my unknown variable, which is my cardinality of A. If you want to change that to an X or just leave it as an A without the in parentheses part, that's totally okay, whatever suits you. To get my cardinality by itself, I would subtract 4 over, which gives me 18. So you will always be given enough information to plug in at least 3 of the values, and then you're just solving for whichever piece is missing. So you can even look at this and be able to come up with some information where if the cardinality of the union of these two sets is 22 and A all by itself has 18, that means there's only 4 elements over here in B that don't also live in A. So you can come up with other pieces of information based on this. Questions on how we use the cardinality formula? Plug and chug.
Hold on, so only 4 don't live in A and B?
Mm-hmm. Because the union is all of it. So if A alone, if this one right here contains 18 elements, and there's only 22 in the union, there's only 4 left over for over here. Now, that doesn't tell me, it does tell me over here how many live in the intersection. 8 live in the intersection. So I could keep filling out this if I wanted to.
So it's kind of just like complex addition and subtraction.
Yeah. Really, when it comes to higher mathematics, that is what addition and subtraction, multiplication and division is. It's how do these sets of numbers interact with each other based on a given rule.
I think, yeah, so we're just like looking at it with all like different rules.
Yep. I'm trying to remember which of my grad classes or undergrad classes it was, but we walked in and on day 1, it was everything you know you have to throw out, and like the first week we had to prove that addition existed. And so we couldn't assume addition worked. We couldn't assume that it played that by the rules. We had to prove it. And it got really interesting. So, are we good with cardinality? Obviously, I'm not going to make you prove that addition works in this class. You can assume it works. It does. All right, let's do another one. This one's a lot like the first one, but we get a lot of different pieces of information in this one. This one we have to remember some of our complements because that's what those little tick marks mean. So it says, Scott, who leads a group of technical agents investigating illegal activity on social networking sites, reported the following information. T is the set of agents that following the patterns on Twitter. F is following the patterns on Facebook. L is following the pattern on LinkedIn. And then we are given a bunch of different numbers, a lot like in the very first problem, where we are going to have to figure out how to fill in a diagram. And we're going to make a diagram since we have 3 different categories that looks just like our last one. Big square, big 3 circles. We're going to label them, and we're going to find out where everybody lives inside these circles based on the information that Scott has gathered. Because our final question for this one is, how many agents are in Scott's group? Because that's one thing we don't know. So we want to know how big is his group of investigators. So we're going to have a circle for our Twitter investigators. We're going to have a circle for our Facebook investigators, and we'll have a circle for our LinkedIn investigators. And all of those live within our universe of investigators for Scott. Because maybe he has some agents that aren't on Twitter, Facebook, and LinkedIn, but are still investigating for him in other ways. So we're going to include that. And then again, I'm going to look through all of my pieces to try and find that center number, see if they give it to me. Because if they do, that helps me then to branch out like we did on the last one. So I know how many are in Twitter, Facebook, and LinkedIn. I know how many share each of those, which will be helpful. And then if I look, the cardinality of T intersect F intersect L, that's the centerpiece. This is always going to be the one I look for first in any given set of information. It tells me that's 5. And this next one is kind of interesting. It says the number of people not in Twitter or Facebook or LinkedIn is 3. So this is the number that lives out here, just in the box, but outside of the circles. Those are 3 agents that are not on those 3 platforms, but still part of his agents. Okay, we've dealt with those. And then again, I'm going to work backwards to fill in the rest of my numbers. Twitter and LinkedIn, those 2 intersect, produce 6. So Twitter and LinkedIn produce 6, so how many go here? 1. Because we already have 5 in the middle. So there's only 1 left over that only does Twitter and LinkedIn. Facebook and LinkedIn has 10. So we would put 5 here. Twitter and Facebook, that would go this way, has 9, leaving me 4. Total number of LinkedIn agents is 13. So how many goes down here in the big circle? 2. Yeah, because I have 10, 11 included in other things. 2 and 3. If you're not getting how I'm getting the numbers, ask. Because that's the most integral part.
So the comma means not, like every time, right?
Yep. Yep. So you don't live in a specific one. So when we had just 2, A and B like this, if I was looking for A complement, what it was everything that wasn't an A, so it was just this over here. Because all the rest of this lies in A. So when you're looking at T complement, it would be all of this stuff besides the T circle. F complement would be everything but the F circle, and L complement would be everything but the L circle. So then once you are combining all of those things together, the only thing left is this outer space, which is how we know that 3 lives out there. So now the only question we're being asked of this one, how many agents are in Scott's group?
25.
Yeah, there's 25. So again, the way that we find it is we add up all the numbers that we have distributed out. So I have 10, 10, and 5, 25. You will not encounter anything larger than 3 circles. So you don't have to worry about having something that has 4 or 5 intersecting circles with 10,000 clues or anything like that. But they do give you different pieces of information on different problems. Are there any questions on this one? Okay, so Venn diagrams are a great way to organize all of our thoughts. Tables are also another way, and you will see at least 1 or 2 tables in the homework. So I wanted to make sure that we did a table problem as well. And the nice thing about the table problems is they come filled in for you. So you will just be asked a couple of questions about it and have to read the table in a similar fashion that we read our Venn diagrams. So Melanie, the officer in charge of the cafeteria on a military base, wanted to know whether the beverage that enlisted men and women preferred with lunch depended on their age. On a given day, Melanie categorized the lunch patrons according to age and preferred beverage and recorded the results on the table. So she has different age breakdowns from 18 to 25. Shows that 45 chose cola, 10 chose tea, 35 chose sweet tea for a total of 90 people. Then there's 26 to 33, and you can see those numbers. And then there's over 33, which I take a little bit of offense that that's the old people category, but whatever. And it shows those numbers with our grand total of colas, iced teas, and sweet teas given. So they give us all this really good information. And then the 2 questions that we are asked is we're asked to find Y intersect C, and we're asked to find O complement union I. Okay, so we're going to look at Y intersect C. That's the youth, the young bucks, intersecting with cola. So the easiest thing to do with a table is you look at it like, okay, I'm going to take the youth row and intersect it with the cola column. It's almost like looking at an intersection in a street. What falls in the intersection of those 2 things? What number? 45. That's all you do. There are 45 people that chose cola that are also considered young. That's what it's asking.
Okay, so the U is not everything outside of cola. That would be the outside, the other side, would it? Question mark?
So union would be taking everybody in the youth column and adding everybody in the cola column if we flipped it. That would we'd be combining 2 different groups. We'd be combining everybody who's young and everybody who chose a cola. When it's intersect, which is the upside down U, we're just looking at what do they share. What is in common. That's the middle part of our Venn diagram that overlaps. So there's 45 people that chose both. Did that help? Okay. All right, let's look at the other question, because this one is a little bit different. It says O complement union the I, which is iced tea. So first, let's figure out what O complement is. Yeah, M and Y. If you are O complement, you are either middle-aged or young. You're not old. So you're looking at these 2 rows. And if you are unioning that with your I column, that is your iced tea. So you are combining it with this. So we can actually, go ahead.
Is it without considering the old people? Or?
We can actually consider the old people with the iced tea because it's a union. And so union is or. You have to live in one or the other. You don't have to live in both. So we can actually include the old people in this one. So we can actually use our cardinality formula that we had earlier because we are asked to find the number of people in a union. The number of people in a union. I'm going to write it with the A and B, and then I'm going to translate that for you with the O complement and show you how this pans out. I ran off the wall a little bit. So since we're trying to find this, we can change it to O complement union I. And what that means is I need to find how many people live in O complement, how many people live in I, minus the intersection of those. And all that information is actually given to us on this table.
Do we have to write the N outside of parentheses every time?
Yes. Because if not, you're finding the union and not the number of elements that live in the union. But outside of the midterm and the final, will I ever know? No. Midterm and the final are the only two times I'm going to actually see your work unless you come and ask me a question. How you do it on your notes and everything is up to you up until I need to grade it and make sure that it's correct. Okay, so how many people are not old? That's what we need to know. Well, they're even nice enough in our table, they give us the totals. The number of young people are 90. The number of middle-aged people are 75. So the number of not old people is 165. And then the number of iced tea drinkers is how much? 65, because that's given right here. And then how many are old and tea drinkers? Or not old, sorry. It needs to be not old and tea drinkers, because this is O complement. It's 35, because it'll be both the young and the middle-aged tea drinkers. So that's 35. So if you do 165 plus 65 minus 35, you get 195 not old or tea drinkers. They can be old and tea drinkers because you can be either one. You either drink tea or you're not old. There's 195 people that fit that category. So just because the letters are different or one of them has a complement on it doesn't mean we can't use our cardinality formula to figure out the information. Questions? I think I remember there being one or two on the homework that had tables instead of Venn diagrams.